When experiencing audio hum after relocating a mixing board, especially with issues in both main and monitor speakers, several potential grounding problems should be investigated. Firstly, verify that the receptacle where the mixing board is plugged in is properly grounded. Use a voltmeter to measure the voltage between the ground terminal and the neutral terminal of the receptacle. A reading other than 0 volts indicates a grounding problem at the receptacle. Secondly, inspect the panel board that feeds the receptacle. Again, use a voltmeter to measure the voltage between the ground bar and the neutral bar within the panel board. A non-zero voltage here suggests the panel board itself is not properly grounded. Thirdly, investigate the possibility of a ground loop between the mixing board and the monitor amplifier. This can occur if the equipment is on different circuits that are not properly bonded. To check for this, measure the voltage between the ground terminals of the mixing board and the monitor amp. If there's a voltage difference, a ground loop is present. Fourthly, to mitigate a ground loop, consider using a ground lift adapter. This adapter breaks the ground connection at the AC outlet. However, remember that using a ground lift adapter can create a safety hazard and should be done with caution. If the above steps don't resolve the audio hum, it's advisable to consult with a qualified electrician experienced in audio systems to further diagnose and address the issue. Remember that electrical systems from the mid-1970s might rely on EMT conduit for grounding, but it's important to ensure this system is still effective and meets current safety standards. For testing purposes with a voltmeter, set the meter to AC volts, typically a range suitable for measuring standard outlet voltage like 120 volts or higher to be safe. When checking the receptacle, carefully place one probe on the ground terminal, the round one, and the other on the neutral terminal, the wider of the two flat slots. When checking the panel board, ensure you're testing between the ground bar, where all the ground wires are connected, and the neutral bar, where the neutral wires are connected. Always exercise extreme caution when working with electrical panels and receptacles. If you're not comfortable working with electricity, it's best to call a qualified electrician. It's important that all equipment grounds are properly bonded together to a common grounding electrode system. This ensures a low impedance path for fault current and helps prevent voltage differences that can cause ground loops. Remember that audio hum is often related to imbalances in the electrical system, and methodical troubleshooting is key to finding and fixing the root cause. Consider the age of the electrical system. Wiring from the mid-1970s may have degraded over time. Insulation can become brittle, connections can loosen, and corrosion can occur. All of these factors can contribute to grounding problems and electrical noise. Visually inspect the wiring for any signs of damage or deterioration. Pay particular attention to the connections at the receptacles, panel board, and equipment. Look for loose wires, corroded terminals, and signs of overheating. If you find any damage, it should be repaired or replaced by a qualified electrician. Also inspect the EMT conduit system. Make sure that all connections are tight and that there is no rust or corrosion. The EMT conduit system relies on good electrical connections between each section of conduit and between the conduit and the metal enclosures of the receptacles and panel board. If there are any loose connections or corrosion, the grounding path can be compromised. The size of the ground wire of the EMT conduit used for grounding is also important. The National Electrical Code, or NEC, specifies the minimum size of grounding conductors based on the size of the overcurrent protection device protecting the circuit. Make sure that the grounding conductor is sized correctly for the circuit. The NEC Table 250.122 provides guidance on sizing equipment grounding conductors for alternating current circuits. If the subpole is a significant distance from the main panel, voltage drop can also be a factor. Voltage drop can cause equipment to malfunction and can also contribute to electrical noise. To minimize voltage drop, use the correct size conductors for the length of the run and the load. The NEC Article 210.19 provides guidance on conductor sizing to minimize voltage drop. Neutral to ground faults can cause circulating currents in the grounding system, which can lead to audio hum. A ground fault is an unintentional connection between a hot conductor and ground. Neutral to ground faults are often caused by damaged wiring or faulty equipment. To check for neutral to ground faults, use a multimeter to measure the resistance between the neutral conductor and the ground conductor at various points in the electrical system. The resistance should be very high, ideally infinite. A low resistance reading indicates a neutral to ground fault. Ground loops can also be caused by multiple paths to ground. This can happen if equipment is connected to multiple circuits that are grounded at different points. The different ground potentials can create a circulating current in the grounding system, which can cause audio hum. To break a ground loop, you need to eliminate one of the paths to ground. This can be done by using a ground lift adapter or by isolating the grounds of the equipment. However, remember that using a ground lift adapter can create a safety hazard and should be done with caution. Isolation transformers can also be used to break ground loops. An isolation transformer is a transformer that isolates the primary and secondary windings. This prevents any current from flowing between the primary and secondary sides of the transformer, which can break a ground loop. Surge protectors can sometimes contribute to audio hum. Surge protectors work by diverting excess voltage to ground. If the surge protector is not properly grounded, it can create a ground loop. To troubleshoot this, try disconnecting the surge protector and see if the audio hum goes away. Sometimes the problem is with the equipment itself. A faulty power supply in the mixing board or monitor amp can inject noise into the grounding system. To troubleshoot this, try using a different power supply or try using the equipment on a different circuit. If the audio hum goes away, then the problem is with the equipment. Consider the overall layout of the audio system. The placement of equipment can affect the amount of noise in the system. For example, placing the mixing board near a noisy piece of equipment can cause the mixing board to pick up noise. Try moving the equipment around to see if it reduces the audio hum. Cable shielding is also important for reducing noise. Use shielded cables for all audio connections. Make sure that the cable shields are properly connected to ground at both ends. Unbalanced audio connections are more susceptible to noise than balanced audio connections. If possible, use balanced audio connections. Balanced audio connections use 3 wires, a hot wire, a cold wire, and a ground wire. The hot and cold wires carry the audio signal, and the ground wire provides a reference for the signal. Any noise that is picked up by the hot and cold wires will be cancelled out at the receiving end. The type of connectors used can also affect the amount of noise in the system. Use high-quality connectors that are properly shielded. Make sure that the connectors are clean and free of corrosion. Dirty or corroded connectors can cause noise and signal loss. Sometimes the problem is not with the electrical system at all, but with the audio equipment itself. For example, a faulty component in the mixing board or monitor amp can cause audio hum. To troubleshoot this, try using different equipment or try having the equipment serviced by a qualified technician. The age of the audio equipment can also be a factor. Older equipment may have components that are starting to fail, which can cause noise. If the audio equipment is old, it may be time to replace it. Also consider the lighting system. Some lighting systems, such as fluorescent lights and dimmer switches, can generate electrical noise that can interfere with audio equipment. Try turning off the lights to see if it reduces the audio hum. If the lights are the problem, you may need to install a power line filter or use a different type of lighting. Other equipment in the building can also generate electrical noise. For example, motors, generators, and transformers can all generate noise that can interfere with audio equipment. Try turning off any unnecessary equipment to see if it reduces the audio hum. If the noise is coming from a specific piece of equipment, you may need to install a power line filter or relocate the equipment. The location of the building can also affect the amount of electrical noise. Buildings located near power lines, substations, or industrial areas are more likely to experience electrical noise. If the building is located in a noisy area, you may need to install a power line filter or use shielded cables. The power quality in the building can also affect the amount of electrical noise. Poor power quality can cause voltage fluctuations, harmonics, and other problems that can interfere with audio equipment. To improve power quality, you may need to install power conditioner or use uninterruptible power supply or UPS. Harmonic distortion is a type of electrical noise that can be caused by nonlinear loads such as computers, electronic ballasts, and variable frequency drives. Harmonic distortion can cause audio hum and other problems. To reduce harmonic distortion, you may need to install a harmonic filter. The electromagnetic interference, or ME, is a type of electrical noise that can be caused by radio waves, microwaves, and other electromagnetic fields. EMI can interfere with audio equipment and cause audio hum. To reduce EMI, you may need to use shielded cables, install a EMI filter, or relocate the equipment. Radio frequency interference, or RFI, is a type of EMI that is caused by radio waves. RFI can interfere with audio equipment and cause audio hum. To reduce RFI, you may need to use shielded cables, install a RFI filter, or relocate the equipment. The building's grounding system is critical for preventing electrical noise and ensuring the safety of the equipment and personnel. The grounding system should be properly designed and installed in accordance with the NEC. The grounding system should consist of a grounding electrode system, a grounding conductor, and an equipment grounding conductor. The grounding electrode system should be connected to a grounding electrode, such as a ground rod, a metal water pipe, or a concrete encased electrode. The grounding conductor should connect the grounding electrode system to the main electrical panel. The equipment grounding conductor should connect the metal enclosures of the equipment to the grounding system. Make sure that all connections in the grounding system are tight and free of corrosion. A properly designed and installed grounding system will help to minimize electrical noise and ensure the safety of the equipment and personnel. Power line filters are devices that are used to reduce electrical noise on power lines. Power line filters work by blocking high-frequency noise while allowing low-frequency power to pass through. Power line filters can be used to reduce audio hum and other problems caused by electrical noise. There are many different types of power line filters available. The type of filter that you need will depend on the type of noise that you are trying to reduce. Some power line filters are designed to reduce common mode noise, while others are designed to reduce differential mode noise. Common mode noise is noise that is present on both the hot and neutral conductors. Differential mode noise is noise that is present between the hot and neutral conductors. Some power line filters are designed to reduce both common mode and differential mode noise. When selecting a power line filter, it is important to choose a filter that is rated for the voltage and current of the circuit that you will be using it on. It is also important to choose a filter that is designed to reduce the type of noise that you are experiencing. Power conditioners are devices that are used to improve the quality of power. Power conditioners work by filtering out noise, regulating voltage, and correcting power factor. Power conditioners can be used to reduce audio hum and other problems caused by poor power quality. There are many different types of power conditioners available. The type of power conditioner that you need will depend on the type of power quality problems that you are experiencing. Some power conditioners are designed to correct voltage sags, while others are designed to correct voltage surges. Some power conditioners are designed to correct both voltage sags and voltage surges. When selecting a power conditioner, it is important to choose a conditioner that is rated for the voltage and current of the circuit that you will be using it on. It is also important to choose a conditioner that is designed to correct the type of power quality problems that you are experiencing. UPS, or uninterruptible power supplies, are devices that provide backup power in the event of a power outage. UPS devices can also be used to improve power quality by filtering out noise and regulating voltage. UPS devices are often used to protect sensitive electronic equipment such as computers, servers, and audio equipment. There are many different types of UPS devices available. The type of UPS device that you need will depend on the amount of power that you need to back up and the length of time that you need to back up the power. Some UPS devices are designed to provide power for a few minutes, while others are designed to provide power for several hours. When selecting a UPS device, it is important to choose a device that is rated for the voltage and current of the circuit that you will be using it on. It is also important to choose a device that is designed to provide the amount of backup power that you need. If you are using multiple pieces of audio equipment, it is important to make sure that they are all properly grounded. This can be done by connecting all of the equipment to a common ground point. The common ground point should be connected to the building's grounding system. Using a star grounding configuration can help to reduce ground loops. In a star grounding configuration, each piece of equipment is connected to the common ground point with its own separate ground wire. This prevents current from flowing between the different pieces of equipment. The length of the ground wires should be kept as short as possible. Long ground wires can act as antennas and pick up noise. The gauge of the ground wires should be large enough to carry the fault current. The NEC specifies the minimum size of grounding conductors. The grounding system should be inspected regularly to make sure that it is in good condition. Loose connections and corroded wires should be repaired or replaced. The grounding electrode should be tested periodically to make sure that it is still providing a good ground connection.